Hello, today we would like to present a new feature of NOMAD that would allow to run automated research workflows within NOMAD infrastructure, so-called NOMAD Actions. First, I would present a general overview and show one example of such an action we were working on. Then Sartak would present several more advanced examples, and finally Ahmed would talk about the framework behind NOMAD Actions. Let us consider typical researcher workflow. The researcher acquires data, maybe from measurements, maybe from simulations, then stores this data somewhere, for example, in NOMAD Oasis, and then they would like to maybe analyze this data, maybe run some calculations, maybe produce an entirely new data set using the existing one. This usually uses some scripts that the researcher have from their PC. These scripts are usually only known to this researcher. The complex pipelines using multiple scripts are difficult to manage and maintain. And let's say a new lab member starts working. They usually inherit a folder of scripts that would be quite difficult to decipher sometimes. Finally, the results of these calculations would be stored maybe in different folders on one PC, maybe in different PCs, and also quite difficult to organize. We offer a possible solution using NOMAD Actions. Those are durable workflows integrated into NOMAD. They can be triggered either within NOMAD graphic user interface or using NOMAD API. They run in multiple steps on the Oasis server. The results of these workflows are saved on the same server within NOMAD Oasis. Both the results and the workflows can be reused by the same user, by different users within group, between different projects, doesn't matter. The example use cases are any kind of long-running calculations, any kind of analysis that require external APIs, external services. Also, the use of additional hardware such as GPUs, or any kind of researcher in the loop situation where first some part of analysis is done, then researcher needs to approve, disapprove, provide additional information, and then the analysis is finalized. The first example we would like to present is the microscopy image segmentation. That project was done together with the University of Ginzburg and Sunplugged. The idea is that there are thin film samples that we would like to analyze for morphological defects. We do that using machine learning based image analysis tool, image segmentation. The practical workflow is following. The experimental data comes as in images and metadata files. They're uploaded to the NOMAD Oasis, parsed automatically, and then the long-running action is triggered to do the image segmentation workflow using pre-trained model. The results of these calculations are stored in the Oasis and can be later cross-correlated with other information on fabrication or other types of analysis also stored in the same Oasis. Here's the example video of running this action. So the data is already, the images and the metadata are already loaded to the Oasis. Now we create an electronic web notebook within NOMAD where we can choose the model parameters, also previously uploaded to the same Oasis. We can add either all measurements in the same upload, or we can manually select which ones we would like to analyze. Here we just add all three. Here you can see some metadata coming with the measurements. We choose some further relevant parameters and trigger the action. Now the image segmentation task takes some time, so we can see the action is running. We can request action status. Well, it's still running. Now the action takes some time, 10-15 minutes for these three images. So we come back later, and here's the second video. Well, nothing yet changed. There is a placeholder for the results, but it's still empty. So now we can request the action status. And we can see that the status changed to completed, and instead of placeholder, we have the actual results. In this case, the image segmentation images and the numerical data corresponding to this image as well. Just in case you're curious, here's the example of such image segmentation action workflow result. Now Sartak would present another example.
The next example is also related to automated measurement characterization. And here we are talking about auto-XRD analysis. It's based on some research done by our colleagues from Berkeley, and we try to bring their workflows in NOMAD. So here we are using actions for two different things. One is for training the model itself, where a machine learning model is trained for a given composition space. And then the model is indexed as a NOMAD entry. And then in a second action, we use this model for running the analysis or the phase detection in XRD data in this analysis ELN. And there we also combine it together with the XRD measurement data already available in the NOMAD as NOMAD entries. And then we trigger a second action for the analysis. We get some identified phases, and then we use this results to update the entry. So we have the trained machine learning model for a composition space as a NOMAD action. And then we also have the analysis as another NOMAD action here. So the result of this would be the phase predictions at for the given X-ray diffraction data. What can happen is that this kind of an automated pipeline is really useful when there is a lot of data coming from high throughput experimentation. For example, here we have a combinatorial sample from the DTU NanoLab, and there are 25 different points of measurement for the XRD. And we use this particular action framework to run the analysis for all of them. It might take some time, but it's very robust. And once you come back after 1 hour of running the analysis, you will have the predictions for this particular phase predictions. Moving on to a different type of application here. This next application is about using a trained model to generate some crystal structures. Again, this is some research done by our colleagues in London. And in fact, what they did was they set up a transformer model for generating crystal structures. And they did train on the data coming from NOMAD. But what we are using here for this action that we set up is simply taking the trained model coming from them and setting up an inference workflow. So we set up this action that can give the input to the trained model. And the input here is setting up a prompt for this generative crystal LLM model. And the start of the prompt is basically like what kind of crystal structures you want to generate. So the name of the composition or something like that. And we use this particular workflow to create a lot of crystal structures, synthetic crystal structures through one action. Here's example. Here's how we do it. And before I get into this, let me tell a brief difference. So in this application, we're using the new GUI. And the new GUI allows you to set up some forms for the action where you can select the settings for running an action rather than having to set up an ELN. And this is what we do here. We go in and upload, we select the run action, and we select the action that we want to run, and we set up the prompt. For example, if you want to generate NaCl crystals or KCl structures. These are very simple structures, but for the example basis. And then we set up some settings and we trigger the action. And we could also take a look at what is happening for the time being. You could see like what are the inputs that you give to this action. There is something called live events where it will show that, okay, it's downloading the model and it will run the inference using that model. And once it's complete, it shows a completed flag. And there are a couple of entries that are created in NOMAD, which shows the result of this inference. And this you can really do for a high throughput, like you could give a list of input prompts containing maybe 500 crystals that you want to generate, and then use that for the action and the inference action. Moving on to non-physical examples here, we also set up an action for exporting NOMAD entries in tabular format. So this is something that was coming again and again from the machine learning community, that they want to use the data coming from NOMAD, but it's really useful for them to collect the data in a tabular format, for example, Parquet file or something. So we again set up an action for this, and this is the form for the action. We have something to input a query, and this query allows you to search NOMAD entries. So for example, here we are building a tabular data set for perovskite solar cell data that we have. And after setting up the settings for this action, we run it, and the result would be, like, it might take around 30 minutes or 1 hour for the whole processing to happen, to collect the data and then transform into these Parquet files. And then it will create an entry in the in your upload, where you, for example, downloaded 218 MB of data in a Parquet file. Yeah, I think Ahmed will show a bit more of how the temporal works, the action works. Spoilers. There you go.
Can you hear me? No? Yeah. Yeah? Okay. Yeah, we're going to talk a bit about agentic AI workflows in NOMAD. So this is also something we can support with NOMAD Actions now. This is like a rough diagram of how an agentic workflow looks like. You have an agent, and then it has a set of tool calls available. The tool calls could also be another NOMAD action. So for example, like the AutoXR, the one that Sartak had shown earlier. And you can have your custom workflows, your external services, and then like the input could be a researcher prompt. Here's an example of a NOMAD agent. So I'm asking like an agent to update the ELN entries, to set a rule in the description field, and then to set the PubChem ID to some number. This is using a Gemma model, which is fairly small, and this is kind of like an easy task. But to be able to deploy this safely, we also need like the human in the loop, so that the human can decide, okay, like the response by the agent looks good. And this is not just about agents. This can be like multi-step workflows where you have some expensive computation that needs to happen only after like the researcher approves. So in these cases, like it's useful to have like the researcher that decides whether to run or provide additional input to the workflow before continuing. And continuing with the prompt, this is how it looks like in the UI. So there's a banner at the top, and then you can provide input. And then this is what the agent has provided. So there's some riddles there, and then there's the PubChem ID. And it all looks good. So there's a form at the end. So in this case, like I as a plugin developer can decide like what the input fields should be. So here I have also like added some feedback, optional feedback fields, and then I can send the response. There are some additional features for groups operating their own Oasis deployment. For example, you can restrict certain actions to a particular set of users or groups. There's task queue prioritization, so that certain workflows can come before others. Fairness, so that like one user running 1,000 workflows don't hog up the entire queue. And observability, so that you have like end-to-end visibility across all of the workflows that are running on your Oasis. And horizontal scaling, so if you want to, as you get more workflows, you want to scale up the number of workers so that you can do this via Kubernetes or Docker by increasing the number of replicas, or using auto-scaling on Kubernetes so that it scales up as you get more work. We didn't build our own execution platform. We are relying on something called Temporal, which is an open source durable execution platform. They provide us a lot of nice features such as automatic retries, fault tolerance, long-running workflows, and so on. And by long-running, I mean days, months, weeks, years, it's fine. and then all of the task priority features, and built-in support for agentic workflows so that they have partnerships with OpenAI and so on to provide these libraries. There are two core primitives here, workflows and activities. So workflows orchestrate the activities, so each one of these blocks would be an activity, and then the workflow decides like what steps to run. And for example, the workflow can have an additional if condition, whether if the validation fails, you can retry the inference step. And this is something also Temporal provides, so you can have retry policy at each activity level. So for example, if PubChem decides to rate limit you, you can retry it like a couple of times so that the whole workflow doesn't fail just because PubChem decides to rate limit you. And worker failures. So what happens if your worker dies at step 5? Temporal will replay the whole workflow only from step 5 onwards, so that you don't have to pay the costs of like machine learning inference again. And it will resume from there, and then you can save the results back to NOMAD. You may not have heard of Temporal before, but this is like something very well used in the tech industry. It's also very likely that you have used some service that uses Temporal under the hood. For example, at Cursor, they use Temporal to run AI agents to the tune of 50 million actions per day. NVIDIA, they use Temporal to run large-scale simulations on autonomous vehicles. And Booking.com uses Temporal to run all of the hotel bookings and so on. And of course, like NOMAD uses Temporal in our processing pipelines. We are a bit smaller when it comes to these players, but we also process around 100,000 entries per month. This is relatively new, as Mark has mentioned earlier. So we are still like learning the architecture, like improving our workflows here. And if you want to create your own action, we have some docs on NOMAD docs. There's a template to get started with, and obviously like the different plugins that already use Temporal. They have their own docs, and if you want help with an agent, there's a Temporal developer skill so that your agent also knows like the best practices when it comes to writing these workflows. And you can point your agent at the NOMAD Actions documentation so that they know how to like integrate it with the plugin structure. So this is something I use with Claude, and it's able to like create a NOMAD action essentially with following the Temporal best practices. That's it. Thank you. And there's a link to the slide if you want to.